Hello friends, how are you? I hope all of you are doing well. Today in this video, we're going to be continuing with the complex numbers, the chapter of complex numbers. We will be studying today about polar form of a complex number. So far in the previous videos, we have seen what are complex numbers, the imaginary numbers, how do you represent the complex numbers, the modulus, the conjugate. Generally, a complex number, it is represented in the form of a plus ib, where a is called the real part, b is called the imaginary part, its modulus, its conjugate. We studied all about that. Now today we will be studying about how to represent this polar form in the polar form. I mean this complex number in the polar form. Okay. All right. A small sometimes confusion happens. Not confusion, but tongue twists. So now we will learn what is the polar form of a complex number. The concept is actually very simple. Generally, how do we plot a point? Maybe when a point AB is given in the coordinate system, how do we plot a point? It's very simple. That is like x-axis, the y-axis, the origin. So to plot the point AB, we go A units on the x-axis, we go B units on the y-axis, and then here we are. We plot the point A, B. That's in the coordinate plane. But in order to plot a complex number, we need a special type of coordinate system, which we do not call it as a normal coordinate plane. We call it as the Argand. We have different pronunciations. So we say Argand Plane. Something like that. Okay. Alright. Argand Plane. Now what happens in this plane is that this is a special kind of a plane where, because see, when you have a complex number, it is a plus ib. So we have the real, imaginary. So what happens with this special plane is the coordinate system, the x-axis is considered as the real axis. Okay, the real imaginary axis. The y-axis will be considered as the imaginary axis, and this as the origin. So again, that will be quite simple to plot the complex number, a units, b units. So this will be my point P, A, B. Simple as that. Now the question is, can there be another way of representing or plotting the point P without using the normal coordinates like a units from the origin, B units from the origin towards the y-axis? Can there be other ways to plot a point or to locate a point in space? Answer is yes, there is another procedure in which we can locate a point in the coordinate system. That is, if we can somehow, so this is the other way, okay? The normal way that we know is how to just plot a point in the normal coordinate system, that is x. On the x-axis we go negative or positive direction. On the x-axis we go a units, on the y-axis we go up or below b units, then we have the coordinate a and b. That's how to locate a point in space when we have 3-dimension. 2-dimension coordinate plane. Can there be other way? What my question was, can there be another way of locating a point? The answer was yes. If I just happen to know maybe what was the distance of the point from the origin, okay, what was the distance of the point from the origin and at what angle with respect to the positive direction of the x-axis is the point located. That means if I can get to know the distance of the point from the origin, and if I can get to know what will be the angle made by the line joining the point with the origin with respect to the positive direction of the x-axis. If I happen to know this angle theta and the distance of the point P from the origin, then also I can locate the point very easily. For example, that is like maybe if I just say there is a point P, no? From which is at maybe 5 units from the origin, located at making an angle of 30 degree, 45 degree, making an angle once again. There is a point located at 5 units away from the origin, which is making an angle of 45 degree with the positive direction of the x-axis. We all know that the angle is always measured anti-clockwise. So in that case, 5 units from the origin and making an angle 45 degree. So that's how we can easily locate the point P also. So the polar form is just another way of, locating a point or representing a point in the coordinate plane, which is for us we'll be calling as the Argand Plane, just using different parameters. Here our parameters were A and B, the x-axis, the y-axis. In this case we just use another parameter, another means, that is the angle theta and the distance r. So this way, this form is called as the polar form, which we plot on the Argand Plane. Okay, so that means in general, let me just summarize, that is there are two methods of locating a point. One is the usual method, the coordinate system. The other method is using the Argand Plane, on the Argand Plane, using just another two different parameters, that is the angle and the distance of the point P from the origin. So just using different parameters. Okay, so now we will be focusing on this Argand Plane, where we use the two new parameters, that is the angle theta and the distance of the point from the origin r, not these two parameters. Alright, that's it. Now the question will be, okay, that is understood, right, that is understood. Now the question is, we will learn about polar representation of a complex number. Now, can we find out the value of r? Because as we have seen, this was the distance A, this was the distance B. Now using this, can we find out the value of r? Just using normal mathematics, normal, think simple, normal conceptual mathematics. Can we find out the value of r? Definitely, because this is a perpendicular drawn. So in this triangle, if I can just use the Pythagoras theorem, because if this is B, then this is also B, this is A, this is also A if needed. Then, if I can just use the Pythagoras theorem, then r square will be equal to what? A square plus B square. Or in other words, r will be simply root over of A square plus B square. This is in line with respect to the complex number. Our complex number we assumed to be A plus IB. In some textbooks, instead of A plus IB, they use different letters, that is X plus IY. So it really doesn't matter. Okay, the letters don't really matter that much. So the value of r, it is easy to find out. So if I have to represent, or if I have to locate a point using the two new parameters, that is r and theta, I also need to find out ways on how to calculate the two new parameters r and theta with respect to the other two previous parameters a and b. The value of r already represented in terms of a and b. Now the question is, how do I find out the value of theta, or how do I find out represent theta in terms of a and b? Don't worry, there is a way for this also. Now look here, in this right triangle again, if I use the trigonometric ratios of sine, cosine or tangent, if I just use, let's say, sine of angle theta, so in this triangle, sine of angle theta will be perpendicular height by the altitude by the opposite side, so that's going to be b by r. So that will be b will be equal to r sine theta. And similarly, in the same triangle, if I use cosine of the angle, then it's going to be base or the adjacent side upon the opposite side, that is a by r. So a will be r cos theta. Let's just keep this for our calculation. Okay, now, okay, maybe I'll just rub it off here. Now the question is it possible to find out the value of theta? Definitely yes, because the new parameter r we already calculated, a square plus b square. What am I trying to do here? I am trying to represent the two new parameters with respect to the other two parameters a and b. Okay, so if I just divide 1 by 2, if I just divide equation 1 by 2, what will happen is, and what are we trying to do here? We are trying to learn about the polar form of a complex number. Our normal standard complex number, the algebraic form was a plus ib. How to represent that a plus ib into the polar form? We are going towards that only. If I just divide equation 1 by 2, I have r sine theta by r cos theta will be equal to b by a. So r cancels. So I have here tan theta equal to b by a. Tan theta is equal to b by a. So I'll just rub it off. If needed, we will write it down again. This is also not needed. So in that case, theta will be equal to tan inverse b by a. Now about tan inverse function, you may not have learned it in class 11. Generally we learn it in class 12 only, that is the inverse trigonometric functions. So for now, what I can just tell you is, as of now, for now, you can just try, know this. That is, what we actually do is, we have another function which is called the inverse trigonometric function. With the help of that inverse trigonometric function, actually here, what we do is, to find out theta, I need theta. What I do here is, actually, I will show you, okay? What I do here is I pre-multiply or I apply the function tan inverse on both sides. Tan inverse of b by a. We are actually not cross multiplying, okay, because as we all know, trigonometric ratios are not product ratios, okay, they are not product of the tangent and the angle, okay, they are ratios. So it's not like, don't assume that, okay, I'm just cross multiplying and it becomes ऊपर चला जाएगा and then it becomes tan inverse. No, it's not like that. We have this function which is called inverse trigonometric functions. We have to apply that function, okay? So tan inverse tan, it's 1. So we have here theta. So that is how we have these values. Theta equal to tan inverse b by a. So there we have it. That is the first parameter r already expressed in terms of a and b. That was, what was r? It was root over of a square plus b square. And the second parameter theta also represented in terms of b and a, that is tan inverse of b by a. So, and this theta, which is the angle made by the position, angle made by the point joining the origin with respect to the positive direction of the x-axis, towards that direction, anti-clockwise. This is also called as argument of, nobody is arguing here, it is called argument of the complex number z, also denoted by argument arg of z. Okay, this is how we denote. I hope you are noting it down. Alright, so we have calculated now or represented theta, the two new parameters theta and r with respect to a and b. So now, look here, this is the interesting part. You will not even know that, wow, you just calculated that. No, it's that simple. See, by the way, what we were trying to do, we were trying to convert the algebraic form z equal to, of the complex number z equal to a plus ib in the polar form, in the polar coordinates, theta and r, in a different, using different parameters, that is the polar coordinates, r and theta. Our z value, a plus ib, this is what we were trying to convert it in the polar form, that is with respect to angle and distance from the origin. Now see, in equation 1 and 2, we actually calculated already the values of a and b. Now all I have to do is just substitute it back here. What is a? That's r cos theta. What is b? That is r sin theta. Okay, so if I can just now, this is not needed for me now. This is also not needed. So in that case, r taking common, I will have cos theta plus I sin theta, and this is called the elusive polar form of a complex number. Okay, so this is the general standard form a plus ib. This is the polar form of a complex number z. So I actually gave you the derivation of, or represented to you, how do we convert it into the entire procedure, how do we convert a normal standard complex number into its polar form. This was the procedure. So all this doesn't happen because of magic. It's just that we use different parameters, and using different parameters we can represent the complex number using those parameters. That is just in another way also. Alright, so right from the beginning, as we mentioned, the point PAB can be represented in using another parameter also. That is, if we can use theta and r, where r is the distance of the point P from the origin, and theta is the angle made by the line joining the point and the origin with respect to the positive direction of the x-axis. Okay, just using two different parameters. So now that means what you will be told to do in the next exercise is you will be given a complex number in this form, a plus ib, and then what they will be telling you is convert this complex number a plus ib into the polar form, that is r equal to cos theta plus I sin theta. That means now in order to convert the complex number a plus ib into the polar form, there are two parameters which we will have to find out, that is r and theta. Now I already gave you how to find out r, isn't it? That's why I derived that also. We derived it, that r was root over of a square plus b square. Done. Theta, how do we find out this angle? Just now only we discussed tan inverse of b by a if the complex number is a plus ib. Okay, now I will give you some shortcuts. Or some working rules on how we can easily actually find out the argument of a complex number based on their coordinates. Okay, this is very elusive. Listen to it. Right, take down your notes and get ready. This is called the first quadrant. This is called the second quadrant. This is called the third quadrant. This is called the fourth quadrant with respect to x, y, x dash, y dash in terms of the Argand plane, where x is represented by the real axis, y represented by the imaginary axis. So normally in terms of coordinates, now this one, because when the complex number is given, it will be first given to you in this form, a plus ib. So first quadrant, as usual, both coordinates are going to be positive. Second quadrant, x-axis negative, y, we all know this. Third quadrant, both negative. Fourth quadrant, positive, negative. Okay. Now the question is, there are three conditions. First condition is if the complex number given to us is purely real. Now regarding that also we discussed, if it is purely real, then z will be only x, that is y is 0. Right, so if z is purely real, that is x, there can be two possible values, that is that the value of x can be greater than 0 or the value of x can be less than 0. That means it can be plus 5 or minus 5. It can be plus 10 or minus 11. No, it can be positive or negative. Now, it's very simple. Listen to it. Please write it. Please write down the notes also. Whenever x is greater than 0, that means whenever the pure real complex number, when the value of x is greater than 0, there's no need to calculate the value of theta, the argument will be 0 degrees. Okay, the argument will be 0 degree. When the angle is less than 0, then the argument will be pi, that is 180 degrees. Alright, this was the first case. You have written it down, you can pause the video and write it down. When this will be now the second case, if z is purely imaginary, I-M-A-G-I-N-A-R-Y, if z is purely imaginary, then z will be, that means the real part will completely gone missing, isn't it? That is x equal to 0. Sorry, very sorry. I use different parameters, you know, A, B and all. So I'll just use, okay, I will just use the same letters, what we were using, I, B. So for the first case, okay, I just use different letters. For the first case, if z is purely real, then z will be A. Okay, don't worry about the letters. That means B is equal to 0. So in that case, either A is greater than 0 or A is less than 0. The remaining things will be same, just the letters. Don't get confused. You must be wondering, oh, all of a sudden now how did the A change into X? How we're from kahan se aa gaya Y and all. Don't be worried about that. Just the letters. I had a small confusion, but remaining things remains the same. Now, this was for purely, this was for purely real. That was the first part. Now just some small corrections with the letters only. Second condition, if z is purely imaginary. Generally we do both the cases. That first part what I was doing was I was doing it with respect to the imaginary, the complex number z equal to x plus iy. That's why. Okay, don't worry about that. So in that case, if z is purely imaginary, then we will have z equal to I into b. That means the real part is 0. That means the real part does not exist. That's why we have this purely imaginary. So here also there can be two cases. That is, the real part, imaginary part can be, b value can be either greater than 0 or b value can be either less than 0. For example, like z equal to minus 4i, no? Or z equal to 3i. Greater than 0, less than 0. In that case also, the value of theta greater than 0. The value of theta will be pi by 2. When the value of b is less than 0, the value of theta will be minus of pi by 2. Theta means argument of the complex number. Alright, these are some working rules. Now, the last working rule, written down, no? Okay, now when the last working rule, that is, when it is neither purely real, not purely imaginary, just a normal complex number, a plus ib. In that case, what we will do is we will find out in which quadrant do the coordinates a and b of the Argand plane lie. That is, for example, okay, listen to, of course we have questions, we will be solving that also, no problem. Suppose if z is 3 minus 4i, in that case what are our coordinates here? 3, real part, and minus 4. Okay, just like we identify coordinates in the normal coordinate plane. Okay, there's no confusion regarding that, don't be confused. So 3 minus 4, where does it lie? 3 minus 4, it lies in the 4th quadrant. We just have to identify like that only. Okay, just in the Argand plane. So it's all the same, almost the same. Okay, so we will have to first identify the coordinates and decide which quadrant does it lie. First, second, third or fourth. Now, respectively, please note it down. Respectively, okay, the value of the argument theta will be equal to tan inverse b by a. Okay, tan inverse b by a when z, I'm going to rub this off now because you may already have written it down in your note. When z lies in the first quadrant. That is, theta will be simply equal to tan inverse of b by a. Don't worry, when we solve the exercises also, we will be practicing. So, if there's a small confusion during the exercise, it will be completely clear. Theta will be equal to, theta means the argument of the complex number will be equal to pi minus tan inverse of b by a. That is when z lies in the second quadrant. Number C, the argument will be can be calculated as tan inverse of b by a minus pi when the value of the complex coordinate lies in the third quadrant. And lastly, theta will be equal to minus of tan inverse of b by a if z lies in the fourth quadrant in the Argand plane. Once again, tan inverse of b by a, pi minus tan inverse of b by a, tan inverse of b by a minus pi, or minus tan inverse of b by a. That's how we can calculate. So these are something like some shortcuts or some hints or some working rules on how we can find out the argument, because the value of r can be easily found out, that is root over of a square plus b square. But for the argument, there are some special conditions, that is if it is purely real, we discuss; if it is purely imaginary, we discuss; and if it's just a normal form, then we have to identify in which quadrant does it lie, first, second, third or fourth respectively. According to this, we can find out the argument as I have given down, this or minus of tan inverse b by a. How do we really calculate this? Some of you may be wondering, sir, actually we haven't studied inverse trigonometric functions. How are we really going to do? Don't worry, as I say, when we do the exercises and all, I will exactly tell you how it is done. For now, at least up to class 11, 12, again we are going to be learning about inverse trigonometric functions. But the concept is very simple, don't worry. So in the next video, we are going to be doing the exercises also. So I guess that's it, because there is a lot of confusion generally with students regarding this polar form, like what is this really polar form, and then so without really knowing what is the polar form, generally students they just do for the sake of doing it. Marks mil gaya, ho gaya and all, but see, it's not a very new topic, okay, it's not a very out of this world topic, it's a very simple topic. It's just that, as I said, we just use different parameters. Okay, today you go to the school walking, tomorrow you are just going to the school in your car, so it's just the mode of transport is different. No, that's the only difference. So normally we plot the points with the coordinate system. In this polar form, we use different parameters. That is the polar form. That is, polar form means in terms of angles, in terms of distance, especially. So we use the polar form, and we just use different parameters. So representing a number in a different way. That is like 2, I can represent 1 plus 1. Okay. Your friend can represent it like 3 minus 1, that is also 2. So different ways of representing 2, okay, but same concept behind it. Alright, so I believe that the concept behind this polar form now will be removed. I mean the problem with understanding the polar form, and if I was helpful in doing that, please share it with maximum of your friends. Let them watch this video also, let them also learn, and yes, please don't forget to subscribe. Alright, and lastly, of course, please do hit the like button also. Alright, and then of course after subscribing, please do hit the bell icon also, so that whenever any new video is uploaded, you can get the notification first. Okay then, see you in the next video with the exercises, where we will be trying to solve the exercises. We will not try, we will solve the exercise. Alright then, till then, take care, bye bye, and stay safe at home.